The Lava Lamp Experiment by Teddy Demetrius. The first step in the experiment is to pour water over oil, and then the water sinks to the bottom, and this is a suspension. It's a suspension because the water, it goes under the oil, and that's because the water is more dense than the oil, and the oil is non-polar, but the water is it's polar. A suspension is a heterogeneous mixture, the one on the right, this one. And a heterogeneous mixture is a mixture that you can see the difference in between, and it's easier to see the difference. Instead of homogeneous, it's harder to see the difference. It looks unified, but it's still a mixture. And a mixture is a combination of substances that will create another substance, but the other substance can be separated pretty easily, and by physical change or physically. And then a physical change is a change that doesn't change the makeup of an atom. It will stay the same material if it's a physical change. Let's just say you burn paper, it'll turn into ashes, but it'll still be paper, or the ashes of paper. But a chemical change, if you make a chemical change, then it'll change into something else. It'll change into another material. So yeah. And there are also chemical properties and physical properties. Chemical properties are properties that are evident in a chemical change, and physical properties are the properties that are evident in a physical change. So back to the experiment. The next step in the experiment is to add food coloring, and food coloring is the solute, and you add it and the solute's what is dissolved in a solution, and then you add it to water, the solvent, and the solvent is what's doing the dissolving, and then this creates water, colored water, and that's the solution, and that's in the middle right there. That's the main drop. And then it starts out there, and then dissolves, and then it goes everywhere. And that turns the homogeneous mixture, because you can't see the difference in between the food coloring and the water, and yeah, just hard to see the difference. The next step was to put the Alka-Seltzer tablet into the suspension, and the Alka-Seltzer tablet is a solid, and it's more dense than the oil and the water, so it sank to the bottom, and the oil and the water are both liquids. And they made a reaction together. H2O is the water, which is the red, since it has food coloring now, and C16H17 NaO14. That's the makeup, the composition of the Alka-Seltzer tablet, and these are all. It makes a compound. Water and the Alka-Seltzer tablet, they're both compounds, and the compounds, they're a combination of elements that bond together. So everything is bonded together. All the elements are bonded together, and it's an element from the periodic table of elements. And if you didn't know, an element is a substance that can't be broken down any further than it is. It's the simplest substance that it can be, and they can obviously bond with other substances with valence electrons, and the number of valence electrons is how reactive. If it has how reactive it is, it has one valence electron, then it's heavily reactive or really reactive, and if it has 8, then it doesn't react, and the reactiveness is how it also bonds. And the H2O reacts with the Alka-Seltzer tablet. The oxygen reacts with the carbon, and then it makes CO2, and CO2 is carbon dioxide, and carbon dioxide is a gas. So it's less dense. So then it starts rising through the oil and the water, and it also brings the food coloring with it. Right there. That's the food coloring and the carbon dioxide. It goes up, and then when it hits the surface, it pops. And when it hits the surface, the food coloring is less dense than the oil. That's why it sinks to the water in like the beginning. And then it sinks back to the water, and then back to the water. That's not supposed to be pointing at the Alka-Seltzer tablet. It's supposed to be pointing at the water, and it sinks back to the water, and then the process keeps repeating until the Alka-Seltzer tablet is like out. And yeah, that's pretty much the gist of the lava lamp experiment. Hope I explained everything pretty well. Thank you.